Our next speaker is Dr. Louisa Marsh. Dr. Marsh joined LGC Forensic, formerly Forensic Alliance, in 2003, having completed a doctorate in materials chemistry. Her expertise in forensic investigations include the examination and reporting of glass, plastics, and other material evidence. Her in-depth specialty is in the identification and investigation of paint. And prior to working at LGC Forensics, she was a formulating chemist at ICI in the UK, developing many different paint types, including architectural paint, spray paint, and other special enamels. Her talk today is entitled "What's on the Highway? Frequency and Occurrence of Paint Shapes Amongst Debris Collected from Road Surfaces."
Thank you. Good morning. First of all, thank you very much for the opportunity to come and talk to you today. My title really reflects a large number of cases I've had in the last few years where I've had clothing in from hit-and-run victims. Unfortunately, quite common. And once you get the clothing in, really sort of drawing on what's been discussed this week, you're trying to give the police perhaps some real-time intelligence. Perhaps there's been no witnesses to this hit and run, and the police really are very interested to find out, well, really anything they can about the victim and possibly who has caused it. Just for a little bit of background information, always good to start with a really busy slide, but the important number here is the bottom right-hand corner. And these are statistics from the UK back in 2006, which is the last available data. And there's 21,000 people injured or killed on the roads in Britain in 2006. And these are all attributed to hit and run. So these are people who've been injured on the road and the person that's hit them hasn't stopped. Breaking it down further, same number to the bottom right-hand side, 21,000. But what this slide shows from the first column is that the vast majority of things are happening on the smaller roads. So not many hit and runs are happening on the motorways. I'm guessing there's less witnesses perhaps on the smaller roads, and so people think they can get away with it. It could also be that small country roads, these are the routes that people are taking back from the pub. They tend to be unmarked and dark, and so it's quite a typical scenario. So taking these factors into account, really, I was trying to decide how to go about this research. And the whole point of it is to try and make meaningful results out of whatever I found on people's clothing. For fear of sounding a bit too patronising, I was a little bit worried that perhaps road classifications were not something that would be particularly obvious here. So I sort of went on Wikipedia and tried to relate some of the classes of roads that we have in the UK with classes of roads that perhaps you guys have here. And looking at the data from where most hit-and-run accidents are happening, I decided to concentrate on some of the smaller roads. The picture at the top is actually just outside my house, and it's a fairly typical non-primary A road. There's no lighting. They can be extremely fast-flowing roads, and this particular one's a 60-mile-an-hour limit. You can really envisage, someone coming along, walking home from the pub, and being hit by a car. Perhaps the person in the vehicle is perhaps a bit drunk and hasn't stopped. So it's quite it's a scenario that you can easily envisage happening. And the unclassified roads are really getting even smaller and even narrower. And they actually make up most of the roads around Oxfordshire, which is where I live. Sort of preaching to the choir here, from a forensic viewpoint, hit-and-run cases are extremely difficult to investigate, as you all know, I'm sure. The victim and the vehicle, or it could be the victim on his bike, perhaps, and the vehicle, are actually probably only in contact for a very short amount of time. I mean, it is possible that people are dragged, and obviously that increases the amount of time in contact. But some of these hit and runs are very fleeting, and so you don't always get a huge transfer of material. And if somebody's perhaps been injured on a windscreen, then it's quite possible to get sort of traces of hair or fibres on the windscreen, perhaps on the broken glass. But that is quite dependent on the police catching the vehicle pretty fast, because it's very easy to get your windscreen replaced and it's very easy to cover up any crime. And of course, without any witnesses, the police really are relying on forensic scientists to give them any real-time information they can. Bearing in mind all the difficulties and some of the cases that I've had to look at, I decided to try and answer a few pertinent questions. And this is what my talk's going to be about, really. I was very interested to find out how common paint chips from vehicles are on the road, and also how common paint chips are on the clothing of people selected at random. And as far as I'm aware, I can't find any data telling me this. I've got colleagues in the laboratory who've all said, oh, it's really common. You know, if you find paint chips on clothing of someone that's been lying in the road, really it could have come from the road, and perhaps we have to temper what we tell the police in real-time intelligence, because there's always the possibility that, you know, someone's been lying on the road. And so I tried to address this. And I'm very aware of the fact that my research has some shortcomings, which would be lovely to address in the future. And one of the big ones really is, just because there's paint chips in the road, does that actually mean that it would be transferred to the victim clothing? And really, I'm afraid that's outside the scope of this, but it'd be nice to look at that in the future. And also, to try and address the significance of the finding. I haven't gone into any kind of comparison for my talk. All I'm talking about really is trying to accumulate enough information to be able to help the police as much as you can, and be able to perhaps guide them as to how much inference you can put on what you find. So here's what I did for my research. I used an extremely high-tech piece of equipment for my collection, and it was an old-fashioned dustpan and brush. And I decided to go for an A3 size. There was sort of method to this, because I figured that was about the right size for perhaps someone's back to be in contact for the road. It was also exactly 3 sweeps of my dustpan and brush, and I should draw attention to the fact that I was standing in the road at this point, and I didn't really want to be hit myself, so fast was good, really. As soon as I collected the debris, I was tipping it into a plastic bag and sieving it, just for ease of searching. And then I transferred all of this to Petri dishes, just to be able to get it under the microscope. And there's a sample here of just some of the Petri dishes that I was ploughing through. There was actually over 100. I actually only sampled 27 samples on the road. I was quite surprised at the quantity of material I was getting off. And it took me by surprise, because I was hoping to collect a lot more samples of this and process them. But 27 was as far as I got over a 3-month period. And I started by collecting samples in the middle of the road. The idea really was to look at sort of samples from all over the road. But what I was actually finding is, because of the camber of the road, there was actually very little sort of debris in the middle. So I sort of moved to the side of the road near the curb, where there was quite an accumulation of material. And I had to be very careful to always sample when the road was dry, because I was very keen to get at the dust, really, the microscopical samples sort of underneath the grit and all the botanical material. And I've searched actually using a 25 magnification low-power microscope. This is just to show you some of the areas that I sampled. I really have tried to do a real mix of different roads, different road conditions. Some were extremely busy, minor roads perhaps through towns, and some were literally in the middle of nowhere, the very, very small roads. And I've also tried to look at various different areas on the road. I was, to start with, trying to target, perhaps hot spots on the road, for example, junctions and roundabouts. I've learned that that's not something that you have a huge amount of in America, but in the UK, roundabouts are sort of every mile, really. And they are obviously extremely dangerous sort of places of collision. So I was really trying to target areas that you can envisage this kind of material being collected. And here's just the weight of some of the samples that I found. Certainly my largest samples are taking up 3 or 4 Petri dishes. And I was quite surprised, actually, at the variation of the different debris that collects. And also, a lot of the sampling was over a millimetre in size, and really most of that was road grit and botanical material. Apart from paint, what did I find apart from paint? Well, when I was ploughing through all these Petri dishes, I was really taking note of anything that was a little bit alien to the environment. And I found, out of all those samples, sort of 100 plus Petri dishes, I found one fragment of glitter. Now, as a trace evidence, obviously that might be of importance in a case, and obviously there's not a huge amount out there from what I can see. Every single sample I looked at contained old glass, and that's really to be expected. I think everybody assumes that old glass is out there and it's very prevalent in the atmosphere and in the environment, but I mean it really was that some of the Petri dishes had many thousands of fragments in there. An extremely high proportion of my samples, 19 out of 27, also contained glass with a freshly broken appearance. Unfortunately, I wasn't able to count, and obviously that's perhaps an area of research that would be great to look into, is what kind of different material is represented by that glass. You know, is it bottled glass? Is it flat glass? Perhaps that's something for the future. And one of those glass fragments actually had a mirrored background, and I'm guessing that's probably from a wing mirror or a side mirror. And there was very little plastic out there, even microscopical fragments of plastic. There was only 3 samples that I found that had little tiny fragments of plastic in it. But what I was seeing again and again with these microscopical glass balls, they came up in many, many different situations. And actually from working in the laboratory, it's something that I see in trace evidence all the time. And I sort of nodded over it and not really understood what it was. But because I was seeing it in such high quantities, went onto Google and found that these materials are actually routinely added on the UK roads, and they're put into wet paint. So if you put sort of road markings down, then these glass balls are tipped into the wet paint, and they're really to increase reflection. And when I presented this to my laboratory at work, there were many nods, and I can only assume I was the only person that didn't know that. But I thought I would share it anyway, because perhaps there's 1 or 2 people out there like me. And really, the manufacturers are saying that there's many different diameters of glass balls that they use. And here's some of the ones that I found which mirrored that. And certainly some samples had maybe 2,000–3,000 of these things in there. So I can only assume that the road surface paints are breaking down, and these things are extremely common. So moving on to paint, the interesting bit. The vast majority of my samples, 20 out of 27 samples, actually had paint in them of some kind. And they were microscopical in size. I didn't find any large chips that you could do perhaps a physical fit with, for example. So they're all between sort of 1 and 2.5 millimetres in size. And in total, over all the samples, I found 191 paint chips, which is, is a very high number. What I tried to do in a single sample and intersample was to try and classify how many different types of paint I got on there. And really, I just did this by eye under a low-powered microscope. So in a single sample, if I'd got, say, 4 blues that looked similar, I would call that one population. So out of my 191 paint chips, I actually counted 113 different populations, and that is intersample only. I didn't do any sample comparison to sample comparison. And a lot of the paint chips were actually containing 2 or more layers, which surprised me a little bit. But what I was interested in was car paint. And when I was searching, I was really looking for a characteristic car paint. I can't say for sure that 191 paint chips weren't car paint. But what I was looking for was very even flakes that had been sprayed. And that's what I found. But out of 191 paint chips, I only actually found 3 paint chips that I would call, with the appearance I would expect of car paint. And they were found in 2 samples. And one of those samples actually looked as if a paint chip had been broken in half. So really, my chance of finding car paint chips and all the samples and of all the debris I found was actually 2 out of 27. And I've got I got some photographs here of the 2 samples that I took and the car paints that I found. So sample number 25, you can see the vast quantity of different paint that's there, and sample number 17. And these are the paint chips that I took out of the sample. I apologise for the quality of these photographs. I didn't really have time to prepare them properly. So I've just taken a side-on photograph just by snapping the paint chip in half. And these are my 2 real random paint chip samples that are of appearance you would expect from car paint. And the top one was actually a 5-layer system, and the bottom was actually a 3-layer system, and that's a blue metallic. This is the second section of my talk, really, and I have to apologise to my colleague Rachel, who spent 3 months working on this, and I've condensed it into a single slide. But obviously she covered quite a lot more than this. But the important thing, really, to get across is that she took 100 random garments and she shook them down for debris, and she pulled out all the paint for me. And of all the paint that she found, almost all of them contained chips of paint. And she's up at over 1,000 paint chips that she found. And I've given you a little bit of information there. Not many of them were more than 1 layer. But not one of the paint chips that she found had the appearance I would expect of car paint. So really, hopefully, I've shared with you, building up a little bit of a picture of what it means to find car paint on a person who's been lying in the road. And as with every aspect of forensic science, there is a huge number of uncertainties. And one of those has to be, how regional are my findings? If I was to repeat this in every county in the UK, would I get the same thing? And if we were to repeat it in a different country, would we get the same thing? I'm not absolutely sure. And the big one really is, just because you find paint chips in the road, does that mean they actually transfer to the clothing of people? I suspect out of all my samples, if I've got 1 fragment in the debris, the chances of that 1 fragment in 100% of the cases transferring to clothing is probably pretty small, but I don't know that. And of course there's physical interpretations that you have to bear in mind as well. Are the roads swept? How big is the camber? Is there been a rainstorm that's washed the debris away into the storm drains? And also, how much has the victim moved around? Have we got someone that's been killed instantly who really hasn't moved, in which case we would expect the persistence to be higher? Or have we got a victim that perhaps has died from their injuries later, and perhaps debris has been dislodged from their clothing? And there's probably many uncertainties I've not thought of. So in conclusion, just to run through some of the statistics I've showed you, we've got a high chance of old glass found in the road. We've got a very high chance that these glass beads are going to be found on people lying in the road. And there's also a very high chance that we've got glass with a freshly broken appearance. And so really those 3 items together, perhaps you would query, finding that really doesn't help the police in an investigation at this particular point. We've also got a very high chance of finding paint. And I was certainly quite surprised how much of that material is in the atmosphere. I mean, it's just everywhere, really. But of those paint chips, very few of them actually come from vehicles, have the appearance to come from vehicles. I've not managed to talk about the different types of paint that I found, but there was a lot of road paint. We found a lot of yellow paint coming in. And there's an awful lot of architectural-looking material that's quite crumbly. So although I would term it paint, it'd be very difficult to work out the origin of it, for example. And taking into account that of the 100 items of clothing that Rachel shook, we didn't actually find a single flake of car paint. So really, I'm more comfortable now in giving the police real-time information and saying, if I am to find car paints, particularly perhaps 10 or more flakes on someone's clothing, that there is a high chance that this actually has originated from the vehicle of the person that's hit them. It was quite interesting earlier in the week listening to some of the conversations and some of the talks that we've heard about where the automotive paint industry is going. Because as far as I can understand, cars are getting better and better all the time. They're rusting less and less. They've got crumple zones, so the plastic materials are absorbing rather than cracking. And actually, paint systems are becoming better. If you were to take a survey, perhaps, of vehicles, I would imagine most vehicles probably haven't got the high quantity of paint chip damage on the front of the vehicle that perhaps they did 20 years ago. And so really things are moving on, and the finding of what we see in clothing, paint chips, really are increasing in value as the time goes on. And certainly I think if this survey had been done 20 or 30 years ago, I think the numbers would have been completely different. I think we would have been seeing, you know, many more different types of car paint. So really it's something to bear in mind that as industry increases their, the things that they do, the way that they do things, it has an effect on what we find and the significance that we can put on things. Just some acknowledgements. My colleague Rachel Hewitson, as I said, she undertook a 3-month placement with us a few years ago. And also for my company, LGC Forensics, who supported me here. And a couple of people to thank, Tina Lovelock, who has been a great source of information and help, and Pam Hamer, who has really helped me come up with the project and has been on the end of confused people talking about their casework many, many times. So thank you very much to them, and thank you very much for you for listening.
Questions for Dr. Marsh?
I have a comment and a question. Just comment-wise, we've seen them painting the roads, and those glass beads are actually thrown on top of the paint. And for the first day after they paint the area, the whole area is strewn with glass beads. So that's part of the reason we see so many.
Thank you. It seems that everyone knew this apart from me. So.
The question is, you say the garments were chosen randomly, but can you give us some idea of the population you chose them from?
We tried to cover a bit of everything. There were a lot of staff clothing taken from work. There were clothing taken from colleagues, sort of family, friends. Really, it was quite they were worn clothing, really. So from all over, generally associated, though, with LGC Forensics.
Okay, thank you.
Thank you.
Hello, I'm David Spence with the Institute of Forensic Science in Dallas. And a few comments. One is I was involved in a racially charged case in Texas a number of years ago. And I would receive some tissue from the victim in a dragging case. And upon examination of tissue, which was not actually a auto-pedestrian accident, but a man that was dragged on a roadway, I noticed a wide variety of different types of paint chips that were all automotive in nature due to layer structure. So I think it is common to find paint chips from other possible accidents on a roadway. The other comment is, I think it might be relevant to sample the area around a victim that's found in the roadway to look at the population of possible paint chips that are found at the crime scene.
That's an excellent point. And if we were involved right at the start with the police ringing us and saying we've got a victim in the road, that's certainly something that I would advise them to do. Unfortunately, we tend to come in much later when it's not been thought about. And as far as your first comment goes, obviously the finding of paint chips in the road, it must really depend on where you're going. And that's always going to be the worry, is that without, like you said, the sampling around it, you can never be absolutely sure. But I'm really looking at perhaps providing the police with some meaningful intelligence rather than being able to say to them, you know, look, this is the colour of the car that hit your victim. So you're absolutely right. There's many uncertainties and edged with caution, but thank you.